A lot of you enjoyed the last space-related video about the planet Venus, so here we are going to look at our galaxy, the Milky Way. That's our planet, Earth, spinning against the backdrop of the Milky Way. Let's take a closer look at this stunning formation. Alright, let's talk about our cosmic home, the Milky Way. Picture it as a massive, swirling neighborhood in space, a barred spiral galaxy that's been around for about 13.6 billion years. It's where Earth hangs out, along with our Sun and a mind-boggling 100 to 400 billion other stars. Scientists are still counting. Oh, and it's got a sprinkle of stardust, about 10 to 20 billion times the mass of our Sun, in gas, dust, and other cosmic goodies. The Milky Way's got a cool shape. Imagine a flattened disk with a chunky bar running through the middle, kinda like a galactic candy bar with spiral arms curling out from it. Those arms, named things like Perseus and Sagittarius, are where a lot of the action happens. It's packed with young stars, glowing nebulae, and clusters that light up the night sky, if you're far enough from city lights to see them. At the center is a supermassive black hole called Sagittarius A, weighing in at about 4 million times the Sun's mass. Don't worry, it's 26,000 light-years away from us, way too far to mess with your weekend plans. Our solar system lives in one of those spiral arms, the Orion arm, about 2/3 out from the center. The whole galaxy's spinning too. It takes us about 225 to 250 million years to do one full lap around the core. That's a galactic year, and we've only done about 20 of those since the Sun was born. Size-wise, it's huge, about 100,000 light-years across, though some recent measurements hint it could stretch up to 150,000 light-years if you count the faint outer edges. For perspective, a light-year is how far light travels in a year, which is 5.88 trillion miles. The Milky Way is our big, beautiful, starry home. A cosmic wonder that's equal parts mysterious and familiar. NASA's flying telescope SOFIA captured a crisp infrared image of the center of our Milky Way galaxy. Spanning more than 600 light-years, the panorama reveals details within the dense swirls of gas and dust, opening the door to future research into how massive stars are forming and what's feeding the black hole at our galaxy's core. The Cosmic Origin Spectrograph COS instrument was placed in the Hubble Space Telescope during Service Mission 4. Its primary science objectives are the study of the origins of large-scale structure in the universe, the formation and evolution of galaxies, the origin of stellar and planetary systems, and the cold interstellar medium. This animation zooms in from our Milky Way galaxy to show the cosmic web, or large-scale structure of the universe. How cool is this? As somebody once said, space is the final frontier. It's truly amazing to think about the sheer vastness of not only our solar system, but the Milky Way and the universe. Even looking at this beautiful visual, pretty much none of us can comprehend the distances involved. If we could travel at 1,000,000 miles per hour, it would take over 67,000 years to go from one side of the Milky Way to the other. And you could fit 804 trillion Milky Ways into the observable universe. And here's the kicker: the whole universe might be way bigger than the observable part, maybe infinite. We don't know for sure because we can't see past the light horizon. A new project using sonification turns astronomical images from NASA's Chandra X-ray Observatory and other telescopes into sound. This allows users to listen to the center of the Milky Way as observed in X-ray, optical, and infrared light. As the cursor moves across the image, sounds represent the position and brightness of the sources. There are plenty of mysteries in our galaxy. Black holes, white dwarfs, and now, hot gas? NASA's Chandra X-ray Observatory has located an enormous source of X-ray radiation at the center of the Milky Way, and astronomers believe that source is an extremely hot cloud of interstellar gas. Astronomers aren't sure how the gas cloud was formed, but how the gas has stayed so hot is the biggest mystery. It's 18 million degrees Fahrenheit in parts and over 180 million degrees in others. Even so, it should have cooled off eons ago. That means something is constantly heating the gas back up again. One theory is that magnetic turbulence or highly energized particles from supernovas are responsible for the heating. Supernovas are the tremendous explosions that occur when certain types of stars reach the end of their lives. This could be the source of the heating, but it's still just a theory. The Milky Way appears in the vastness of space behind the SpaceX Dragon crew spacecraft docked to the Harmony module's space-facing port on the International Space Station. The Milky Way is pictured from the International Space Station near the top of this long-duration photograph with a camera programmed for high sensitivity. This long-exposure photograph from the International Space Station was taken during an orbital night period and reveals the Milky Way glittering above a bright but exaggerated atmospheric glow blanketing the Earth's horizon. These four nebulae star-forming clouds of gas and dust are known for their breathtaking beauty. The Eagle Nebula, which contains the pillars of creation, the Omega Nebula, the Trifid Nebula, and the Lagoon Nebula. A team of astronomers made rough distance measurements to some of the stars in these nebulae, and were able to infer the existence of the Sagittarius arm. Their work provided some of the first evidence of our galaxy's spiral structure. Similar structures, sometimes called spurs or feathers, are commonly found jutting out of the arms of other spiral galaxies. For decades, scientists have wondered whether our Milky Way's spiral arms are also dotted with these structures, or if they are relatively smooth. The Cat's Paw Nebula, imaged here by NASA's Spitzer Space Telescope, lies inside the Milky Way galaxy and is located in the constellation Scorpius. Its distance from Earth is estimated to be between about 4,200 light-years to about 5,500 light-years. The bright cloud-like band running left to right across the image shows the presence of gas and dust that can collapse to form new stars. The black filaments running through the nebula are particularly dense regions of gas and dust. The entire star-forming region is thought to be between 80 to 90 light-years across. The stars that form inside the nebula heat up the pressurized gas surrounding them, such that the gas may expand. The green areas show regions where radiation from hot stars collided with large molecules and small dust grains. Here's another image of the Cat's Paw. The star-forming nebula W51 is one of the largest star factories in the Milky Way galaxy. Interstellar dust blocks the visible light emitted by the region, but it is revealed by NASA's Spitzer Space Telescope, which captures infrared light that can penetrate dust clouds. There is so much more to explore in our Milky Way, so if you enjoyed this episode, please hit the like and subscribe buttons, and check out our other videos for more super wow cool moments. Thanks for watching, and see you on the next video.